Let's look at some exponential growth models. So an exponential growth model, I typically think about with this formula. The amount that you currently have is the initial amount, with money you'd call it principal, times e to the r times t, where r is the rate of growth and t is the time. Now, I use the same variables as money because biological organisms grow very similarly to money. But you could use P naught equals e to the kt equals p. You've got different variables in these three slots, but it's the same equation. Let's look at this problem. You find 4 sprouts of grass in your planter. After 1 year, you have 95 sprouts. If this rate continues, how much will you have after 2 years? Okay, well, let's look and see what happens here. The first step that you have to do in these problems is typically build your model. The initial amount was 4. After 1 year, that's your time, you're up to 95 sprouts. So I can figure out what kind of rate this is. I'm going to divide by 4 to get a basic exponential equation. Now I'm going to take the natural log of both sides, or you could think of this as converting to a logarithmic equation. I'm going to approximate r. Now, if you want to, in fact, I'd advise that you keep the entire 12 digits of r that your calculator keeps in the calculator while you calculate the later pieces, but I'll probably just write down these 4 digits. Okay, now the question is, if that rate continues, how much will you have after 2 years? So I have to go back to the original model, and I have to say, I want to know the amount, starting with 4, having a rate of 3.168, after 2 years. So I calculate this out, and it predicts somewhere around 2,256 sprouts. So is that an accurate growth model? You know, you'd have to make those predictions using your intellect to say, okay, I think this is reasonable, or I think this is not likely to continue a second year. Similarly, when will you have 1,000,000 sprouts? So this is an interesting question. Now, you might say it's not reasonable to have 1,000,000 sprouts in this area, but maybe it is reasonable. So let's have a look at what the model predicts here. Now, I'm going to go back. Again, I have my initial amount of 4. I have my rate. I don't know the time, right? When is what I'm solving for, but I do know I want this to equal 1,000,000, right? I'm going to get a basic exponential equation by dividing 1,000,000 by 4. Now I'm going to take the natural log of both sides. I'm going to divide by this 3.168. Here's where, if your calculator remembers more digits, it's great to use them all. And that predicts you'll be up to 1,000,000 in about 3.9 years. Wow, that's quick growth. And that's an exponential growth model.